All right, we're about to start a new chapter, H12A, H12B. I'm going to have a number of different videos to explain this. So we're going to start off with the warm-up that they give in the textbook. And this chapter combines everything that we've been doing in Chapter 3, Chapter 9, I think Chapter 8 too, and Chapter 11. Oh my gosh. Okay, so let's start off with the warm-up. Find the antiderivative of this. So the antiderivative of this, the antiderivative of 2x is going to be 1/2 of this, but since we have that 3, we have to have that there, plus the antiderivative sign is cosine, and since it's 5x, we're going to have 1/5 times 2, and that's going to give us this plus c. Okay, if you're not sure how I did this, this is chapter 11. I did some substitution stuff there to just look at chapter 11 if you need help with that. Okay, find the vector that is perpendicular. So in chapter H3M, if it's perpendicular, then we're going to use the cross product. Okay, and if we're doing the cross product, then we have 1, 2, -1, cross 2, 0, -3. Okay, and as you may or may not recall, so this is going to give us a 3x1 matrix, and I'm just going to use 3 different colors here. Hopefully this will help you recall what we're doing here. Okay, so the resulting vector is going to be perpendicular. So this first row is going to be 2 times -3 minus -1 times 0. And so notice my very first row does not have any of the blue numbers. Okay. We'll simplify that in just a minute. Now my middle row is going to have only the pink and the blue. So we have -1 times 2 minus 1 times -3. Okay, and this middle one does not have the yellow numbers there. Okay, and then the bottom row doesn't have any pink numbers, so it's going to be 1 times 0 minus 2 times 2. Okay, and if you don't remember the order of which ones go where, you definitely should look at your formula packet. And in your formula packet, it's here on page 8 of your formula packet, and it tells you how to do cross product, just in case you forget the order of what goes where. Okay. Okay, so let's simplify this thing that we just put together. So now we've got this top row is going to be -6 minus 0. This next one's going to be -2 plus 3, because minus negative. And then the next one's going to be 0 minus 4. Okay, so that simplifies to -6, 1, and -4. Okay, and so the cross product gets us a perpendicular vector. That's going to be really important in our new lesson. Okay, find the scalar. Find and use the scalar and velocity products of the two. So we want to find the angle between these two things here. So this vector is 1, 2, -1. And this vector here is 2, 0, -3. Right? Since there's no j written here, we know that that value is going to be 0. Okay, so we're going to so to find, first of all, to find the angle between two vectors, we use this formula here. Now what this top part is saying, v dot w over the magnitude of v and the magnitude of w. So we're going to find the dot product of the two vectors, and we need to find the magnitude of v and the magnitude of w. So let's do that right now. Okay, so the dot product of, okay, and you may want to look at H12A to review this process if you've forgotten. So to do the dot product, we simply do 1 times 2 plus 2 times 0 plus -1 times -3. Okay, and that gets us a scalar value of 2 plus 0 plus 3 gives us 5. Okay, and then now I want to find the magnitude. Remember, those lines mean magnitude. So the magnitude of that is 1 squared plus 2 squared plus -1 squared, which is going to give me 1 plus 4 plus 1 is going to give me the square root of 6. And then I need to find the magnitude of 2, 0, and -3. And that gets me 2 squared plus 0 squared plus -3 squared. It's going to give me 4 plus 0 plus 9, which is the square root of 13. Okay, and so the formula that I showed you on the thing is cosine theta equals v dot w divided by the magnitude of v and the magnitude of w. Okay, and we just found all three of these things. So so now to find our angle, I'm going to write cosine theta equals our scalar product, which is 5 over the magnitude of v is square root of 6. The magnitude of w, the other vector, is square root of 13. And if I plug this into my calculator, I get approximately 0.566. And then, so if I do my inverse cos of that value, I end up with 55.5 degrees. Okay, and as I recall, we pretty much just do this in degree mode. Okay. I don't believe we will be using radian mode in this chapter. I could be wrong, but I don't think we're using radian mode. Oh my gosh, eigenvalues and eigenvectors. Woohoo! Okay, so first of all, we need to, okay, this is section H9I if you need to review that. So we start off with A minus lambda I times vector x equals 0. Okay, and we need to remember that I is our identity matrix 1, 0, 0, 1. Okay, and so we're trying to find what's going to make this equal to 0. So to make a minus lambda I equal to 0, we need to find the determinant. Okay, so matrix A is 2, 3, 1, 4, and minus lambda, so times I. So minus lambda and 0, so it's just going to be 3, and then this is going to be 1, and this is going to be 4 minus lambda. Okay. This formula, if you've forgotten it, is this in the, maybe it's not. Okay. Well, okay. So the minus lambdas here came from lambda times the identity matrix. Okay. There's no lambdas here because the identity matrix is 0 and 0 there. Okay, like I said, if you need a review, refresher, you can watch the H9I video. But anyways, we need to make this equal to 0. So in order to figure out the determinant, I'm going to have this times this minus that times that. So I'm going to have 2 minus lambda times 4 minus lambda minus this guy here, so 1 times 3, and we're going to make that equal to 0 to find our determinant. Okay, so we can FOIL this out, and I get 8 minus 2 lambda minus 4 lambda plus lambda squared minus 3 equals 0. Okay, combine my like terms. I get lambda squared minus 6 lambda plus 5. Okay, equals 0. And then this is going to help us get our eigenvalues, so we can factor this out, and we can see what two things multiply to give me 5 and add to give me negative 6, and we know it's going to be 5 and 1. So I'm going to have lambda minus 5 and lambda minus 1. So my eigenvalues are lambda equals 1 and lambda equals 5. Okay. Now we've got our eigenvalues, and we need to find our eigenvectors. So, so we're trying to make a minus lambda I equal to 0, right? So for lambda equals 1. Okay, so I'm going to take this matrix here and replace lambda with 1. Okay, so 2 minus 1, and then 3 and 1, and then 4 minus 1. Okay, so I've just taken this matrix here, and I'm replacing lambda with 1. Okay, and now I'm going to have x and y, and then equals to 0. Okay, so now let's simplify that. 2 minus 1. Well, that's 1, right? And then 3, and then 1, and 4 minus 3. 4 minus 1, that's 3, right? Okay, so now I can rewrite this as one equation. So 1 times x gives me x, 3 times y gives me y, and then equals 0. Okay, so now we want to solve for x and solve for y. So I could subtract 3y on both sides. I get x equals negative 3y. So basically, when y equals 1, then x is going to be negative 3 times 1, so x equals negative 3. And using that information, my eigenvector is equal to negative 3, 1. That's my first eigenvector. All right, now for lambda equals 5. We're going to, instead of plugging in 1, we're going to plug in 5 in for lambda. So I've got 2 minus 5, 4 minus 5. Okay, that simplifies to negative 3, 3, 1, negative 1. Aren't you glad I gave you so much space for this warm-up? Okay, so basically we can take the first row and this. So I got negative 3 times x plus 3 times y equals 0. And so I could add 3x on both sides. I get 3y equals 3x. So quickly we can say that we know that when x is 1, we know that y equals 1. So that means my other eigenvector is going to be 1, 1. So these here are my my two eigenvectors. Okay, and we'll be using eigenvectors and all this stuff in this chapter. Okay, so the critical thing to note here is these two things. I'm not going to write it down to save time. Okay, so quantities which need direction are called vectors. If you don't need directions, it's called a scalar. And we can also refer to it as magnitude, right? So scalars have no direction, they just have a measurement. Okay, so a quantity without direction is a scalar. Quantities with direction is a vector. Okay, all right, so let's look at the first example. A force given by vector 2, 5, and a second force is given with this vector. Okay, all right, and here's a picture. So what is the total horizontal force experienced here? So the horizontal force is the x part of the vector. So this x part and this x part added together is equal to 2 plus 3, which gives me 5 newtons. Okay. The vertical force is up and down, right? So vertical, the up and down values of my vector are 5 and -2. So we simply do 5 plus -2, and we get 3 newtons. Okay, number 3. Hence, write down as a column vector the resultant force. So I'm adding the two vectors together. So the resultant force is this first vector, 2, 5, plus this other one, which is 3, -2. And so my resultant force is going to be 5 and 3. Okay. Number 4, find the magnitude of the resultant force. Okay, so magnitude is often write it like this, right? And so to figure out the magnitude, we take the square of the 5 plus the square of the 3, and then add them together and take the square root. So 25 plus 9 gives us the square root of 34. And then I plug that into my calculator, and that is approximately 5.83 newtons. At any time, if you need to hit pause or replay, you should do so. Okay. Okay, question A. Find the magnitude and the direction of the forces. Give the direction as an angle measured counterclockwise from the positive x direction. Okay, so what we have here, so I could think of this as 6, 3, right? In the x direction, I'm going 6 units. In the y direction, I'm going up 3. So I want to find this angle here and call it theta. So to figure out that angle, I can use tangent, right? I'm going to write SOHCAHTOA on the top to help me remember things. Okay, so I've got the opposite side, I've got the adjacent side, so I'm going to use tangent. So I can say tangent theta equals opposite over adjacent 3 over 6, and so which is 1/2, right? So I can do the inverse tangent of 1/2. I plug that into my calculator, and I get 26.5 degrees. Okay, let's do question B. Okay, so hit pause anytime you need to. Okay, question B. In the x direction, I'm going -3. In the y direction, I'm going up 4. And I'm going to call this alpha. And it says we're going counterclockwise from here. So when it says from the x-axis, basically this is 0 degrees, and we're going counterclockwise. Counterclockwise means we're starting here at the x-axis, and we're going counterclockwise. Okay, so what I'm trying to figure out, so here's my x-axis, I'm trying to figure out this angle here, and I'm going to call that angle beta. Okay, so we need to figure out this angle here. So, in order to figure that out, I think it's easiest to use tangent. Tangent is opposite over adjacent, so tangent alpha equals 4 over 3. I could plug that into my calculator, and I get um, uh, the angle is equal to 53.1 degrees. Okay. Now to find angle beta, then I'm going to have to do 180 minus 53.1. And then angle beta is equal to 126.9 degrees. Okay, hit pause if you need to. Okay, question number 2. Write down the following velocities as column vectors. Okay, so we know that we're going a magnitude of 7 and a bearing of 45. So remember, for bearings, north is 0 degrees. Okay, if I'm going a bearing of 45, bearings go clockwise. Okay, so we need to remember that bearings move clockwise. So if I'm going a bearing of 45 degrees, I'm going to be going this way. Okay, and the length of this is 7. Okay, so this length here is 7. Okay, and if we're going to write this as a column vector, it's going to look like x and y. So I need to know how far am I going in the x direction and how far I'm going in the y direction. So this is also 45 degrees, because that's a 90-degree angle, right? And so we need to figure out this value and this value here. So if I'm finding, oh my gosh, y and x. Okay, so let's do one thing at a time. So to find x, I know that this here is adjacent, and this here is the hypotenuse. So if I'm doing adjacent and hypotenuse, then I'm going to need to use cosine. So I can write this as cosine 45 equals adjacent over the hypotenuse, which is 7, right? And so adjacent is my x value, so I can write the adjacent is equal to 7 times cosine 45. Okay, remember that. This process, you may have to watch it again. We need to find y, and to find y, this is opposite, this is the hypotenuse, and we know that length is 7, so if I'm using opposite and hypotenuse, I'm going to use sine. So now I can rewrite this as sine 45 degrees equals opposite over the hypotenuse, which is 7. And so now I can rewrite the opposite side, my y value. I can rewrite the opposite as 7 sine 45. And now I can use this information to write my velocity as a column vector. So I can write this as 7 cosine 45, and here I can write this as 7 sine 45, and then I get, this is all for question A, right? And then I simplify that on my calculator, and I get 4.95 meters per second. That's the answer for part A. Okay, so A was not a big deal. If I made a mistake, I'm still going to get the same answer. But for B, it's going to be a little more tricky. So we got to make sure we know our sine and cosine values carefully. So we know it's 12 meters per second at a bearing of 330. So okay, and okay, so if I'm going at a bearing of 330, then that means I'm going all the way till about here. Okay. So that means this little angle right here, that angle is going to be 30 degrees, because all the way around adds up to 360. Okay. So okay. So to figure out the, let's see. If I'm using the 30 degrees, this is my x direction, this is my y direction, right? We know the length of this line here is 12. Okay. So to find the x value, I'm dealing with opposite and hypotenuse. So if I'm dealing with opposite and hypotenuse, I'm going to use sine. So I can say sine of 30 degrees equals opposite over hypotenuse. Okay, so now we're solving for x. So if I can cross multiply, I get x equals 12 sine 30. Okay. I think I've made a mistake somewhere. Y is adjacent. So we get cosine 30 equals adjacent over hypotenuse. So y over 12. And we get y equals 12 cosine 30. Okay, I may have made a mistake somewhere, because this is showing that my column vector should be 12 sine 30 and 12 cosine 30. And my answer key says it's switched around. So you might see a follow-up video on question 2b, because this should simplify to 6 and 10.4 meters per second. So I am going to come back to this to make sure I didn't make a mistake. Okay, question number 3. Okay, particle experiences the following acceleration with 3 different components. Find the magnitude and direction of the resultant acceleration. Okay, so the resultant force is, we just have to add these together. Okay, if I add all this together, I end up with -1/6. Okay, and So now this is my resultant vector. And so to find the magnitude, I'm just going to simply say -1 squared plus 6 squared, and that's going to give me 1 plus 36, and that simplifies to 6.08. Okay, and now the direction. So starting from here in the negative, I'm going this way 1, and I'm going up 6. Okay, and we're trying to figure out this amount here. Call that beta. We're going to call this alpha. So I can say tangent opposite over adjacent. So tangent of alpha is going to equal to 6 over 1. And so then, tangent, the inverse tangent of 6 is going to give me alpha. So alpha equals 80.5 degrees. So now to figure out this angle here, the direction. So if this is north, right? And I'm going all the way to here. And now I know that this is 80.5. Well, from here to here to here, there's 3 90-degree angles. So the 90 plus 90 plus 90, that's 270. So to figure out from here to here, I'm going to have 270 plus 80.5, and I'm going to say I have 350.5 degrees. Okay, question number 4. And then I'll hit pause for this video. For question number 4, the torque is produced when turning an object with force acting at the end of the lever displacement, and the torque is written like this. Okay, state the direction of the torque compared to the other two vectors. If I'm using the cross product, then that means the torque is perpendicular. It's perpendicular to F and R. Okay. And then question B, find the magnitude of the torque produced from the force and the displacement here. So to figure out the magnitude of the torque, I first need the cross product. And then I'm going to find the magnitude of a cross product. So the cross product of 3, 4, and 0, and 2, 1, and 0 is going to be equal to, the top row is 4 times 0 minus 0 times 1. Then the middle row is going to be 0 times 2 minus 3 times 0. And then the bottom one is going to be 3 times 1 minus 4 times 2. Okay, and that simplifies to 0, 0, and 3 minus 6 is, no, 3 minus 8 is 5. Okay, so so we're trying to find the magnitude of the torque. So now we have to figure out the magnitude. We need to take the square root of these values here, and you should quickly see that the square root of 5 squared is simply 5. Okay, and that is H12A.